Hello,
Yeah. Hello, I'm audible.
sir.
Yeah, let's say I'm audible.
Yes, sir.
All right. So, for the moment, I'll be sharing my screen. Okay, let's take this one. Yeah. So, I think today I have to I have to start with trigonometric session, right? Okay, I've shared my screen. Is it visible to you?
Yes, sir.
It's visible, right? Phone is showing issue with this. Yeah, no, leave that. I'm sharing you another screen. I think you can see the blue screen, right?
Yes, sir.
Okay, fine. So, yeah, do we have to start it from scratch, or you have already studied something in trigonometry?
Yesterday we studied, sir. Yesterday introduction was given, sir.
Okay, introduction of the chapter was given. Right? Mm, okay, in the introduction part, which things were covered? What were already covered in the introduction?
Sir, sine theta, how to find sine theta value, using right angle triangle and,
Okay, so basically, the last session is more about the triangles, right?
yes,
Sine they have taught, cos or tan was discussed or not?
yes, sir.
Okay, just discussed. Mm, Basic identities you have discussed. Right? All right. So let's start with the session back.
Okay.
So basically, in trigonometry, we generally start with a triangle. So we already have previous session in which you can see we have this kind of triangle, right? So this is theta. Let's say this triangle A, B, and C. With respect to this theta, the line, the side which is just in front of this, maybe you can call this one CB in this case. So for this theta, okay, for this particular theta, this is going to be your perpendicular. The adjacent one is going to be your base, and the third one is going to be hypotenuse, right?
Yes, sir.
We by using Pythagoras theorem, we are well aware with an equation that this h square is going to be sorry, this h square can be rewritten as h square this p square. From where we are getting this equation using Pythagoras. Let me try this. Okay, makes sense. Now, how we are going to relate the things in trigonometry? So, yes, in the last session, as you just told me, that if I wanted to represent this into the sine of this theta, right? Sine of this angle is theta. So this side, by the formula which I am going to get is perpendicular because it is in the front of it and dividing it by the base, right? For the cos, I am going to get this thing. What is it? Base upon hypotenuse. Sorry, should be hypotenuse. Yeah, cos of this theta will be nothing but base upon h. And what is the last one? That is tan of theta. Tan of theta is nothing but ratio of both of them. Okay, ratio of the sine of that angle, cos of that angle. That will result to the this thing. Okay, sine of this theta divided by cos of this theta will result to perpendicular divided by h, base divided by h, and this will let you give this p by. Okay, this is something which you are going to do. Okay, let's talk about this cos of it. So assume that I'll take different example for this one. Assume that you are having a mirror over here. This is a mirror, and assume this is a rod. This is a line or rod, something, right? So with respect to cos, let's talk about how what is the physical significance of this. We can see. I have this rod, okay? So if I ask you of this rod, which portion you are going to see in this mirror, what portion of this mirror, what portion of this rod is going to get projected in this mirror? I will say the portion, basically this portion, right? From this point to this point. This point is going to get projected on this mirror, right? If there's a source or there's a way to see it from the top view, you are going to see this length only in this mirror, right? How you are going to get this? This is angle theta, okay? If I ask you, okay, I'm just giving you this angle theta, so you can say, sir, I know the cos theta, okay? I know this cos theta will be nothing but the base b divided by h, because I said this is the height of a rod which may be given to you, and I'm asking what is the length of the rod which you're going to get projected in this mirror, so that you can put it over here. So b comes out as h of cos theta, okay? Uh, yes, this is one thing. These things you will be studying, these things you will find usable in your physics, okay? Too much, this projection part and all. So this is where we can actually see this part. Okay, another sense of this you can say is, I said this is the angle you are getting, right? If I put mirror over here, what portion you are going to see in this mirror? I don't know this angle actually. I don't have any angle like this. But I can say that this is sine. So whatever the length you are going to see over here is this much. This is the length, right? We can call this as perpendicular. Why this is perpendicular? Because this is parallel to this line. Maybe let's call this as O point. This is A point. This is B point, and this may be M point. Okay, so you can see this O to M is parallel to A to B. Okay, because they both are parallel, the points are coinciding. Basically, they are the same length. So you can say OM have same length as AB over here. Okay, but in this case, O or A is not parallel to B, right? It is not parallel. So in that case, you can say the length of the AO, which is going to projected on this OM is nothing but just basically the length of OM itself, right? How you are going to calculate that? You can simply say, sir, I know the sine theta. That is going to be equals to perpendicular upon the hypotenuse, which is P by H. What is that P? That is AB divided by what is that H? That is O to A. Makes sense. What is AB? I have just told you that is O to M. So that gives you OM by A. So you can say that this OM length comes out equals to 4 times of A times sine of theta. Some kind of uses we are going to have this kind of things. Okay. Mm, all right. So, are you aware of some identities, or I can start with I can just assume that you only know about the three formula, that sine theta, cos theta, and tan theta.
Yes.
Okay. So, if I just go by this assumption, we can move to trigonometric identities. Right?
Okay, sir.
Some formulas or some relations which are going to be useful in future cases. Before going further, I would like to ask about the theta. What is this theta actually? Okay. So here we have in with respect to this triangle, we have seen this is theta, right? This angle, how much angle is it is creating. So you know, complete angle is how much? 360 degree. Okay, which is a part of a complete circle, basically you can say. Okay. This angle is generally represented into two forms. One is radian and one is, yeah. Angles can be represented into two forms. One is degree, one is your radian, right? Most of the time, maybe till now, right, you must have you have seen the angles in the degree, right? When I'm writing like 45 degree, when I'm writing like maybe 60 degree, when I'm writing like 90 degree, when I'm writing like 180 degree or something, okay? So before going to next, I wanted to give you an introduction on radian as well. So what radian is? So by convention or by knowledge, whatever we have, 180 degree is equals to pi. Now you will say, sir, what is pi? We are well aware with the pi that pi has a value of 3.514, which is approx. In general, it can be written as 22 by 7. Right? This is the value of pi, right? Okay. So, Today, I think it's better to start with a interconversion of these two units. Okay. So here we can say degree versus radian. Look, the basic problem with the degree part is you can't do a normal addition subtraction with other units, right? It's not a other it is not going to act as another unit, okay, which radian can actually do. For example, if in your equation you are having some mass in future, not time, mass is there, time is there, something division is there. If you do this and multiply it or divide it by theta, which is if you keep it into the theta, degree in the theta, the answer will be incorrect. Here we generally keep it into the radian, okay. So this interconversion is useful in this part, at this part. Yeah. So let's talk about it. Just I told you that pi is equals to 180 degree. Okay. What does this mean? If I say, if I divide both sides with 180, what I'm going to get? 180, a scalar value I'm talking about. So it will come out as pi divided by 180. But you can actually do one thing. You can divide degree by degree. You can add degree by degree. Okay. Same units can be yes, can be added, subtracted, multiplied, or divided. What you if two things have same unit, you can do all four operations in general. Okay. So here you can see you have 180, so you can actually divide it by 180 itself. So what answer you are going to get? That is 1 degree. Okay. It means 1 degree consists of pi by 180 radian, right? This is what it is all about. So instead, if I ask you what is the value of, okay, if I ask you just to try to convert this 45 degree into radian, so what will be the answer? You know, each degree consists of this much radian. So we can simply say that just multiply this. This side is into the theta degree. Okay, here this is into the radian. So what will the answer? This thing, right? Pi by 180. Okay, so before moving further, yes, are you clear with this thing?
Yes, sir.
Okay. Any doubt so far?
No, sir.
No doubt, right? Okay. So, okay. All right. Let's do one thing. Let's do some interconversion units. I'll give you. I'll ask some questions. So first we can do one thing. Okay. Let's do one thing. I'm giving you a value, maybe 22 by maybe 63, right? I wanted this value to be converted into degree. So can you tell me the answer for this one? This is in the radian right now. This is radian. Okay?
Okay, sir.
Yes. Uh, okay, you don't need to get into the complete decimal value. You can let me know just a fraction place value. You don't need to do complete division. Okay, should I give the solution for this one or you are trying to solve it?
I'm trying to solve it, sir.
Okay, all right. So, so far, whatever steps you have done, you can just let me know that once.
Okay, sir.
Mm, I think it's too much time already. Okay, wait. Whatever you have done, that's fine. Look, here the question is, you are given a radian unit, okay, which you need to convert into degree part. This is what you need to do. How you can actually do this? In previous case, I have done opposite. I gave you like how much one radian, how much 1 degree contains, like how much radian is contained in one degree, right? 1 degree contains pi by 180 radian. So here what you did, you basically when I told you convert this into this radian part. So because 1 degree contains pi by 180 radian, how much radian can be contained by 45 degree? You can simply do one thing, just multiply it. So you can see when you multiply both sides, you got the answer. So this method, when you don't have any formula, okay, you have these kind of identities. When you apply them, we call them as a unitary method. Okay? Unitary method means to say you know the value of one item of basically whatever it is, 1 unit or something. When I gave you a bigger unit, you will simply multiply with that. Okay, maybe yeah, some Excel. Let's call this one. It's a very simple answer that if one pen cost 5 rupees. So 10 pence, what will the cost of 10 pence, right? That will be just 5 into 10. This is basically a unitary method. The same we are going to apply above also, right? How? Let's see. Look, from the previous discussion, you can scrap out this pi is equals to 180 rupees, right? Okay, makes sense. I need radian. Right now, I don't have any unitary value for the radian. What I can do is, I just told you same units can be divided. This side I have radian. So what you can do, just divide both sides with pi. The moment you do so, you are going to get 180 divided by pi. Okay. This is a unitary value of radian. So 1 radian is equals to 180 degree by pi. Right? This is what it is all about. So when I ask you 22 by 63, it's a simple, you just do multiplication. You just multiply 63 by, sorry, it is 22 actually. You simply multiply 22 by 63 with this particular 1 radian. What is the value? 1 radian. So instead of 1 radian, because I told you, you need to calculate this value, right? Here must be some unit that is respecting it as 1 radian. We know the value of 1 radian. What is that? This much. Substitute this 1 radian with this degree part. So what you are going to get? 22 by 63 into 180 degree by 5. You can see here, here we have converted the radian into the unit degree part. Okay. So yes, if you like, you can actually go further and divide and solve this thing. So it's like pi can be written as 22 divided by 7. This goes with this. This goes with 9. Okay. This goes with 20. So 20 degree will be the answer for this problem. Okay. So this is a small unitary method you can actually use. And this one more thing, this unitary method can be used at anywhere. Okay. So yeah. So here we started by saying there's two ways to measure angle, right? One is degree, one is radian. We have not gone very deep about this degree and angle. Okay. In general, if I ask you what is just an angle about, what is this angle? So angle is basically the measure of rotation. So what is that rotation? Okay, let's do one thing. Actually, I should have started with angle by saying what is an angle. Let's space some here. So what is an angle? Yes. So assume I have a rod. Okay. I have fixed this. I have basically two rods. Okay. Just like this. I have two rods. Okay. You can see both are parallel to each other. Basically, they are coinciding. And this point, about this point, they are pivoted out. So what you did, you kept one rod as it is. You took another. This you pull this point upside. When you pull this point, assume that you take it by some distance x to upside of it. Maybe this distance is x. Makes sense. So for this, from this side, how much rotation you did? How much rotation you did? So this for this rotation, this angle is the measurement. Okay. What is the angle? Angle is basically the measurement of rotation. Measurement of rotation. Understood? If you move more, this theta will increase like this. Measurement of your what I could say, this rotation. This is nothing but an angle. Now it's all about I'll say how we are going to taking an angle. In general, convention is saying that if you are saying this is y-axis, if you are saying this is x-axis, most of the time the angle is taken from this x to y. So whatever the angle you are taking, maybe this is x-axis, this is y-axis, this is going to be taken as positive, and the bottom is going to be taken as negative. Okay, why? Because yeah, this side is negative for the y, this is negative y, right? So we are saying this angle is a positive. So whatever you do opposite, that is always taken as a negative. Okay? So I wanted to know, are you clear with the concept so far till now, whatever we discussed?
Yes, sir.
Clear, right?
Yes, sir.
Okay, fine. So let's go more into the radian, not just by measuring them to each other. Basically, the complete revolution in general, a complete revolution in a circle. If I create a circle over here with respect to the center, a complete revolution, because I just showed you the measurement. Yeah, measurement of the rotation is known as angle, right? So when you start moving from here, when you go out, complete circle. Assume you reach only till here. So what is the rotation you did? You went up to this rotation, right? Assume you finally reach back to the same position. Then how much rotation in that case you are going to do? It will be this. This is right. So a complete revolution is known as the rotation, the measurement of rotation in a complete in one revolution is 2 pi. Okay. From there we discuss about the radian. So radians. If you have to write the definition of a radian, it's basically one revolution. Uh, the measurement. Yeah. So basically the measurement of angle about a complete revolution. One complete rotation can be termed as one radian. Okay. So yeah, this is a small definition about the radian. Yes, the value of did I write somewhere? No, it should be that is one radian. Okay. What is the value of this one radian? That is 3.1. Okay, so just tell me, is it correct? Whatever this definition says, is it correct or not?
Uh, no, sir.
No, right? Okay,
No.
so why it's not correct? Because I have just told you earlier that one radian consists of pi, right? One radian is equals to pi and it consists of 180 degree. And here I'm saying a one complete revolution can be termed as one radian. No, it's not. Why it's not? Because one complete rotation consists of 360 degree, which is 2 pi radian, right? So instead of
Okay.
this, understood? So yes, this is basically 2 radian, okay, alright, which is equals to how much? 3.14. Let's not put the value over here because we already know the value about this. Okay, yeah, where 1 radian is equals to how much? Pi by 180 degree. Okay, that is all for the values for now. So yes, we have seen a small conversion part. I don't think we should go much more into the conversion over here. Yeah, actually we can go a little bit. What if I say, can we convert this minus 45 degree to radian? Example, let's keep it as something. Yeah, let's say like, can we keep this 45 degree into the radian? Mm, wait, I'm not audible. I'm not realizing. Yeah, my question is like, can we actually convert this one minus 45 degree into the radian part, into the radian unit? Plus,
No, sir.
no, why we can't convert?
Negative, sir. It's negative.
Okay, so does it mean that negative is not an angle? Because look, we have seen so far that if I have an angle in one unit, in basically if I have angle in some unit, I can convert it into another unit, right? This is a unit method we can follow for this one. So why can't we apply the same thing over here? Because I said, what is angle? Angle is nothing but a rotation, measurement of a rotation. It means if I'm saying I have a like I'm saying look, one thing you need to always keep as positive, other will always become negative. For example, I'm saying this if I move from here to here because this is positive direction, so I'm keeping this as a positive direction. It means if I start moving in opposite direction, I'm always going to take it as positive. Okay? Can we do the same thing in angle also? Yes. For example, if I'm measuring my rotation in this direction and I have made this convention to be positive, okay, then if by anyhow I made my rotation towards downside, I will always take that as a negative. Okay. Assume that there's two person over here. I have a rod over here. Just assume that I have a rod, which is just I have kept this rod on this rod itself. Okay. Now what I did from this point, I started moving this. I started moving this, but I am not telling you how I'm moving actually. And finally, I kept this rod like this. Now there's two ways to keep this rod in this situation. What are those two ways? I'll write it here. One way is very simple. Instead of moving in this way, I will simply go in this negative side and keep it here. Another way is going by complete revolution. Understood? So assume that uh, you came to me like you are seeing this picture after I did this operation. So how you are going to identify whether you have to take this value as positive or what? Because you know if you are going in opposite direction, it is negative. If you are going above direction, it will be positive. Does it mean that this angle is always positive? The values or the calculation which we are going to will it get affected by this or what? Because I don't know what is this angle right now, but I know one thing that this is 90 degree, this is also 90 degree. If I go bottom part, this is also 90 degree. Summation of all these becomes out at 270 degree. So you have covered some distance in between this. You have covered this angle. In this direction, if you go, the hole is 90 degrees, so you have covered something around uh, minus 90, okay, minus 90 degree to some angle 0 degree, right? 0 is mean to say this point itself, and this negative minus 90 is this point. So you are in between something, right? By convention, if you say in trigonometric, how we are going to using that, we are going to say both angle are the same. This x or this x we are keeping it as same. Okay, we'll discuss this how they are same at the end of the day. Okay, we are going to discuss this afterward. So yeah, the my main point of the saying is you can actually do this. You can actually do this conversion. Okay, one way is first convert this negative part into a complete angle part. Okay, how you can do this? You know the complete angle is 360 degree. This is a small portion you are given as 45, basically negative 45, right? So can I say the positive side of this angle is nothing but 360 minus 45 degree, isn't it? In calculations, you may or may not be you may or may not be using it like this. Okay. So either this way is this. So this will come out as how much? 315 degree, right? Or and now you can actually go and convert this. Another way is simply don't do anything. Okay, simply just multiply it by what? Minus 45 into 5 by 180. This will directly land you to the value. Okay, clear? This will directly land you to some what I can say a radian value, right? Even if you see this division is very clear, you can this thing will come out as minus 5 by 4 radian. This negative has very high significance. It suggests that you are at opposite side of it. Okay, you are at this side. Okay, so Lasya, if you are clear with this thing, please let me know. We can try to move to the next part. Mm, Yeah, Lasya, should we continue? Like, should we move further?
Yes, sir.
Okay. So let's talk about a unit circle. I'll be taking a very simple a unit circle. So unit circle I have taken over here, which means the radius of the circle I'm keeping as 1. Okay, 1 radius is there. This is x-axis you can call. This upper y-axis you can call. Okay, makes sense. Okay, how angle we are going to represent over here? Again, I said the rotation, right? 30-degree rotation will land you somewhere here. 60-degree rotation will land you somewhere here. Then you will reach 90 degree, right? This is 30 degree, 60 degree, and 90 degree. Okay. If you have ever used compass, you can actually you can actually get another angle by dividing them. You know this is 0, this is 90 degree. You wanted to get yes, yeah. You can actually get 45 degree. How you are going to get the 45-degree angle? If you do angle bisector of this 90 degree, you can get a angle in between this. Okay, this is what actually you can do. For this, you can basically put your compass at this point, okay, and make an arc over here, maybe somewhere here. From this point also, you can make another arc. The point where it is lying, that will be the center of it. So that's how you can get the another angle as well.
Yes.
Right. I don't want to see this one. Okay. So this is about a unit circle. It will be go in the same way. Now, trigonometry, actually, we are going to use it. In general, in trigonometry, you don't need to remember the complete circle. I don't prefer others to remember the complete circle part. If you are well versed with this 0 to 90 degree values, you can actually create the rest of the values by yourself. Okay. For that, you should be clear with what angle is used for what kind of thing. Okay. For example, I just told you minus 45 and 315 are nearly same. Okay. Yeah. So here we are talking about 0 degrees, 30 degrees, 45 degrees in general, 60 degrees, 90 degrees. Okay. These five values you need to remember for three ratios. Basically, this sign here, right, ratio, sine, cos, and tan. Okay. For these three ratios, you just need to remember these five values. Let's say a look here. Maybe it might be there. So you just need to remember these five values. Okay. The rest value you can get it by yourself. How? I'll explain this part after this. So I don't think I must have told you, but yeah, there's an easy way to get the sine value. Okay, the same way we are going to do for the cos as well. The same we are going to do for the tan, because we know the tan is nothing but a ratio of sine of that angle divided by the cos of that particular angle, right? That will result you the tan itself. Okay. So, with respect to a circle, how we are going to define this sine theta, cos theta, and everything. Look, when I said this is a unit circle, let's remove the things. I am saying this is my radius, right? This is my radius, r. Okay. So, what is the projection of this r on this length? We generally call this as this, whatever the angle you have made, this becomes r of theta, right? This becomes r of cos of theta. Okay. This projection is known as r of cos of theta. So that's how we come up to a different kind of ratios. Basically, we can use this relation x square plus what I can say plus y square is equals to r square. So this is basically equation of circle if I wanted to keep over here. Okay, are you aware with the equation of circle?
Sir, we have in textbooks, sir.
Okay, fine. Yeah, I also wanted to. You must have. Okay, that is a different thing. Leave it for now. Okay. Mm, what we can discuss. Look, when we talk about the sine, cos, and tan, you can simply say these in this circle, whatever the projection at the bottom, okay, this cos gives you the ratio of the bottom and the real length, okay. The sine gives you the projection in the vertical part and or the real length, and the tan gives you the projection of basically ratio of both, okay, this and this part. This is what you can use in concept of circle, okay. So we have these 0 to 90 degree values. You can start putting it by saying, okay, I'll keep 0, then here I'll keep 1, here I'm going to keep again 1, here also I'm going to keep 1 and 1. Will it be helpful in any ways? I don't think so. What you need to keep, you need actually, okay, sorry, it should be 2, 3, and 4. What you need to do, divide everything by 4. The moment you do so, you are going to get this. And lastly, just put an under root over there. This is the value of this sine and that particular angle. Okay. For cos, you just need to do the reverse of it. Reverse of it mean to say where you started in case of sine from 0, here start from 4. 4, 3, 2, 1, 0. Again, so I'll just directly write over the answer. That will be 1 itself. Here it will be root 3 by 2. Here it will be 1 by root 2. Here it will be 1 by 2. Yes, 1 by 2, and here it will be 0. Okay, because at the end of the day, when you start from 4, you will reach here by 0. So there is a opposite symmetry, or by the angle, if you see, the things are falling behind by 90 degrees. Okay, or if I make some angle of this sine or now, small angle, I think I can try to do. So if you plot it, sine value and the theta value, here let's say I'm saying this is 30, 45, sorry, this is 45, 60 and 90 degree. If I try to plot this, it will come up like this for sine. But in case of cos, how this plot is going to come up like this? The plot is going to start with 1 and it is going to lead by this, it is going to get like this, like 0. So this kind of plot you are going to get for the cos. Okay, but after this 90 degree, after this 90 degree for sine, these values are going to get like this. So if you see carefully, because I have not told you about the values of the rest, for the sine, sine is also following the same path, but after 90 degrees, right? Or you can also say this cos is following that path, but 90 degrees earlier of the sine. Okay, so let's say, look, yeah, I have another class just now. So that's all for the today's discussion. Before ending, you can let me know your doubts, whatever you wanted to wanted to ask. We can cover that first, and then we can have the session by then. If you have specific questions or something, you can let me know.
No, sir.
No questions, right?
Yes.
Hmm, okay, fine then. Uh, we have not discussed too much. You can just practice some conversions if you want.
Okay, sir.
Okay. So yeah, that's all for the session. Goodbye.